have two types of histogram depending with the nature of the data. So if the data has a uniform class width, so we draw for a uniform class width, we draw a frequency against class boundaries so that you have frequency on the y-axis, then class boundaries on the x-axis. Remember, we use the upper class boundaries. For varied class width, or if the class width or interval is different, we plot a frequency density against the class boundary so that you have frequency density on the y-axis and class boundary on the x-axis. So we shall see later how do you calculate the frequency density, and also how do you identify the class interval class widths. So from this question here, so you want to see the first question here, determine the value of x. So remember, x is a missing value here from the column or from the row of frequency. So we know that total frequency is normally given as the total number of participants taking that case, and for this case we are using candidates which are 100 candidates. So we say the total population, which is summation of frequency, is the same as the total number of frequencies inclusive of the x that is missing. Therefore 100 is equals to the sum of the others, which gives you 78 plus x, making x to be the subject to get it to be 22. State the model class as the second question. Remember, the model class comes from the one that has the highest frequency. So this is 22 as the value of x. This is 24, and then the others are lower than 24. Therefore, the highest frequency here is 24. We have our model class of 35 to 44. Remember, if they say a model mark, then you come for that class that has a model frequency, then obtain the model mark from the value of x. Remember, to get this value of x, you simply add this one plus this one, then divide by 2. That is 35 plus 44 divided by 2 to get 39.5. Then the next question here is to calculate the median. So how do you calculate the median? Median is given by this formula, the lower class boundary plus brackets total frequency or total number of participants divided by 2 minus cumulative frequency before that class, then divided by frequency of that class multiplied by the class interval of that class if it's of a varied class interval. So therefore, total number of frequency for our case was 100 divided by 2 gives us 50. So we come and replace here with 50. Using that 50 will also give us the lower class boundary, so that having that 50, you come to the column of cumulative frequencies. So that 50 lies in between here. It is above 40 but below 70. That means it's inside here. So you come with this row to this class here, so that you find that 50 is lying between here, and taking the lower value to be 45, the lower class interval becomes 45 minus 0.5, minus 0.5, or in other words, 45 plus 44 divided by 2, which gives us 44.5. So therefore, our lower class boundary becomes 44.5, then plus this n over 2. 100 over 2 was 50, so 50 minus cumulative frequency before that class, so cumulative frequency before this one is 44. So therefore, it is minus 44 divided by frequency of that class. Frequency of this class that it's lying is 14. So therefore, divided by 14 multiplied by the class interval. The class interval is the same as 54 minus 45 plus 1. That gives us 10. So we multiply here by 10 to get our median as 48.7857. And calculate the mean max. We want to see how do you calculate the mean max. Remember, mean is given by summation of fx over summation of frequency, which we come here to get fx. To get fx, fx is given by the multiplication of the value of x, which is the midpoint, times its frequency to get this one. So you sum up these values to get 5010, then sum up the frequencies, which gives you 100 from also the cumulative frequency. So then take this summation of fx over the summation of f, which gives you these values to obtain 50.10. What of mode of grouped data? To get the mode of grouped data, we are using this formula that mode is given by the lower class boundary of the class that has the model frequency, then mode plus that model frequency minus the frequency before the model frequency divided by 2 times the model frequency minus the model frequency minus the frequency after the model frequency multiplied by the class interval of that model frequency in case it has a varied class width. So therefore, replacing this value to get our model frequency as F1, so we come to this table again and analyze. So the highest frequency is 24. This is the model frequency. Therefore, our class is 35 to 44. So therefore, the lower class boundary is obtained by this lower mark, which is 35 minus 0.5 to get is 34.5. So come and write here 34.5. Then plus the model frequency is 24, which is the highest frequency, minus the frequency before the model frequency. The frequency before the model frequency is 14. Therefore, it becomes 24 minus 14. Then the frequency after the model frequency also is 14. So you come and substitute here, divided by 2 times the model frequency minus 14, which is before, then after is also 14, times the class interval, which is 10. Then from the calculator gives us 34.5 plus 5, which is 39.5 as the model mark of the grouped data. And kindly subscribe and share to get the next lesson. Have a nice time.